let's start with rule number one. Now, rule number one is that atoms with high atomic number at rank or take precedence or take priority over atoms with lower ones. So in the sense that the first rule is very easy here. So it's not that too difficult. So if, for example, here you are comparing two atoms like this, here you have bromine and what and fluorine. Do you understand? Now, when it comes to electronegativity, do you understand? The one that have more electronegative power, fluorine attract what bromine. Do you understand? So we are not talking about electronegative power. We are talking about in priority. You understand? So bromine has higher atomic number than what? Has higher atomic number than what fluorine. Do you understand? So now, what is the atomic number of bromine? The atomic number of bromine is what? Is 35. The atomic number of fluorine is what? Is 9. Do you understand? So bromine attract what? Fluorine. So it means that bromine greater than what? Than what? Fluorine. Do you understand? So we are comparing two elements or groups. Therefore, look at the one that have higher what? Higher atomic number. Another example is what? Carbon and what? Hydrogen. Carbon and what? And hydrogen. Carbon is what? 6. Hydrogen is what? Is 1. It takes what? Atomic number. Therefore, carbon is greater than what? Than what? Hydrogen. So the rule number one is very easy. It's not that difficult. So now, but let's look at another one here so you get the understanding. If, for example, now you are comparing what? OH and what? And COOH. You look up. Now, this one you are seeing here, that this is your first element. That is the point of attachment. If you look at the O molecule here, now the functional group here, that the functional group is directly attached to somewhere. Do you understand? And how do you know if it's attached to somewhere? Where the isomer is attached to. Yeah, that is attached to oxygen here. That is oxygen you are looking at. Here you are looking at what? At carbon here. Right? Now, oxygen, what is the atomic number of oxygen? Oxygen is what? Is 8. What is the atomic number of carbon? Carbon is what? Is 6. There. So in the sense that when you are doing your ranking, you don't look the whole compound. Just you look what at the first atom. Look at what the first atom here. So here we have oxygen, here we have carbon. This oxygen is attached to hydrogen. This carbon is attached to OOH, COOH, right? But it's not important here. It is the first element that your focus will pay attention to. Do you understand? So the oxygen, that is your main element here, is what? Or your main atom is what? Is 8. Carbon, your main element here is 6. So it means that because oxygen is higher than what? Carbon when it comes to what? Atomic number. Therefore, this guy will attract this one here. So OH, which alcohol, will attract what? COOH when it comes to what? Priority what? Rule. Do you understand? Now let me give you another example just so you understand here. If, for example, here we have NH2, and here we have CH3 here. Look at it here. This and this here, which will attract each other. Here we have nitrogen, right? Nitrogen, the atomic number is what? Is 7, right? Here we have carbon. Carbon, the atomic number is what? Is 6, right? Although this nitrogen have 2 hydrogen and this carbon have 3 carbon. If you check it, this guy just like CH3, and what? CH3, right? Now, but your main concern is not this one here. It's not the one attached to it. Do you understand? Your main concern is this carbon here. Do you understand? Now, this carbon is what? Is 6. Nitrogen is 6. That is what the major point there. Do you understand? It does not matter if the rest ones. It does not matter. The rest does not matter, right? So this guy, because nitrogen attracts carbon, despite carbon is having 2 carbon here, it's not important. As far as the first element attracts the first element here, that is it. Do you understand? So this guy will attract this one here. Do you understand? So that is what we call rule number 1. Now from rule number 2 to rule number 4 is very important here, because this aspect normally used to get confused when what priority rule. So let's look at what rule number 2. Rule number what? 2 is very important here. But before we look at rule number 2, let me give you one for you to try. Just let me give you one for you to try. If, for example, here we have CH3, and you have chlorine. Now, which one is higher? Is it A or B? A or B? Right. Now, let's say this one is 1, 2. If you should have something like this, NHCH3, and you have now, is it A or B? So leave your answer at the comment section here. This one, which one will attract which one? This one, which one will attract which one? You have C, CH2, 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 and you have fluorine. So which one will attract which one? A and B. So leave your answer at the comment section. I want to see what you can do. So that is what rule number what? That is what rule number 1. So let me to watch rule number 2. From rule number 2 to rule number 4, like I said, this is where things begin to get complex, right? So let's move to what rule number 2. Rule number 2 state that when two atoms directly attached to the same carbon double bond identical, compare the atoms attached to this atom in the base of the atomic number. Precedence is determined at the first point of difference. Now let me explain to you here. Now, if you now have two compounds here, that first atom have the same atomic number. Let me give you a good example here. So you have CH3 and you have CH2, CH2, right? Now, what would be which one? Which one here? Now here we have carbon. Your first element here, carbon. Your first element here is carbon, right? What is the atomic number of carbon? 6. What is the atomic number of carbon? 6. Fine. So the first elements, they are the same. So they don't have problem. So you cannot use the first element to attract the atom again. Unlike when you have something like this, chlorine and what? Chlorine and what? CH2. Chlorine is what is 17. Carbon is what is 6. This guy will attract this guy here, right? But here, carbon and carbon, right? Carbon is 6. Carbon is 6. Now, because carbon is 6, what we want to look at now is the group that is attached to it. If you look at this compound here, here we have carbon here having what? 3 hydrogen, right? 3 hydrogen. This carbon here having what? 3 different hydrogen, right? Now this one, hydrogen and what? CH2. So if you check very well, hydrogen are the same. Hydrogen are the same. But hydrogen and carbon, they are not the same. Can you see that? Now, because this guy have carbon, one carbon, I can see that one here. This guy will attract one. So now when I say CH3 and what? CH2, what happened here? CH2 attract what? CH2. Can you see that? Can you see how easy it is, right? So you look at what the group that is directly attached to it. So that is going to be what? The second one. If, for example, I have something like this. If, for example, I have CH2, CH2, right? And I have something like this. C. If you check this guy here, you have this carbon here. You have hydrogen and hydrogen have CH2, right? So that is this carbon here have what? 1 carbon attached to it. Yeah, what is the other one? You have hydrogen, CH3 and what? CH2. This one have what? 2 carbon attached to it. And you have CH3, CH2, CH2. Now to you now, which will be the highest priority here? Of course, the one that have 3. The one that have 2 will attract the one that have 2, and the one that have 2 will attract the one that have what? 1. Just now, because the different here is what? Is this one here, the methyl group. Because the carbon, they are what? Carbon, yes. 666, right? So you're not going to check them based on what is directly attached to them. So this one have only 1 carbon, so I have 2 carbon, so I have 3 carbon. Just now, so this guy is less than this, and this one is less than this. Now this one is greater than this. So whenever you have something like this, it means that here we have CH3 is greater than what? CH3 is greater than what? CH3. Here we have C2CH2. Can you see that? That is rule. So that is what rule what number 2. Rule what number 2. It's not more than this other one. You just understand? Rule number 2. So let me do what rule number 3. Rule number 3. Rule number 3. Work outward for the point of attachment, comparing all atoms attached to a particular atom before proceeding further along the chain. So now let me explain to you. If, for example, you have CH3 here, and you have CH2. Now, like what I said, these things are very, very technical. So that is why you need to master the rules step by step. You get. Now, if you look at this one here, this carbon atom here is having 3 different groups. 3 what different groups here? Here we have CH3, and what? CH3. Can you see that? This carbon itself and this one, hydrogen, C. Here we have H2 and what? So it is saying that when you are comparing two compounds together here, you must therefore look at the first carbon atom here. Atoms that are directly attached to it, you get. If for example here we have CH3, right? And here we have CH3, CH2, Cl. If you check this one here, please pay close attention here. If you check this one here, now 6 and 6, right? Carbon, right? Here we have CH3, here we have CH2. It means that they are the same, but based on this, they're almost the same here. But this one here have what? Chlorine. Right? Because if you check very well, CH3. Here we have CH3, here we have CH2. It means that here we have CH2 and hydrogen. That is meaning, right? So hydrogen and chlorine, which are attracted to each other here. Chlorine attracts hydrogen. Do you understand? So this guy is less than this. Why? Version of his what? Because of this what chlorine here. Now, but when you are comparing compound like this here, CH3, this carbon here have a 3 different carbon. Do you understand? This carbon here, what are directly attached to it? 2 hydrogen and 1 carbon. Although this carbon here have OH attached to it, but the OH is not important here. Do you understand? The OH is not important. What is important is that when you look at this carbon here, what is directly attached to this carbon is what? This carbon and 2 what? Hydrogen. This carbon here we have 3 what? Carbon here. Because this carbon have 3 carbon attached to it, and this will only have 1 carbon attached to it and 2 hydrogen. This guy will attract this guy here. Just and so this will attract this. So when you are comparing atoms here, when you are comparing molecules here, therefore check all the atoms that is directly attached before proceeding further. Do you understand? So when you check this carbon here, when you check the atom that is directly attached to this carbon here, carbon, hydrogen. Of course, this one will attract this. Just all like this one here, carbon, right? But here we have carbon, CH3. Here we have CH2, CH3. Just so what is difference here? What is the point of difference here? The point of difference is on hydrogen and chlorine. Just so chlorine will attract here because of chlorine here. This one is higher than this other one here. Just all like the other one here, carbon, hydrogen, carbon. Just so this guy is greater than this. Just so let me talk about rule number 4. Rule number 4. When you're working atoms for the point of attachment, always evaluate substituent atoms one by one, never as a group. Just so that this will be able to explain to you now. Very, very important. Pay attention. So if for example you have CH3, just I have CH2OH. Fine. Now at first, when the person see this come over here, they say, now let me ask here, this and this, which one will have higher priority? Is it A or B? Let me hear from you. We have some A and B here. Which will have higher priority? Leave at the comment section. I will explain. Leave at the comment section. Okay. So in the sense that if you check very well, Majority of places will take this one. Large majority of students will take so here because not the reason why because this guy have three hydrogen. If you check very well, three carbon. CH3, CH3, and what CH3. Can you see that? And here we have carbon here, hydrogen what OH. Now, what they are telling you is that never evaluate suspect atom as a group. Never, never evaluate as a group. Now, let us say that because this will have three methyl, therefore, you are transfer them. No, you must compare them one by one. Now, this carbon, this one is having carbon, which is six, carbon six, and what carbon six, right? Now here we have hydrogen and hydrogen. But this carbon also attached to what to an atom or element that is having higher atomic number than any of these ones here. So this guy is what is eight. Now because oxygen has what higher atomic number than what this carbon, and than this carbon here. Now because of oxygen here, because this carbon atom here carry oxygen, carry a group that is having oxygen. What happen here? This guy will attract from one. So never evaluate substituents as a group. Always evaluate what one by one because oxygen is far greater than what carbon, and what carbon. Do you understand? So you don't like group them. No, you don't group them. You take them one after the other. Now because oxygen is directly attached to this carbon here. Do you understand? Oxygen is what? Oxygen is directly attached to this carbon here. Oxygen will attract carbon, and what carbon. Due to that, this guy here, CH2OH is greater than what CH3 here. Now, but when you also like what I explained before, but when you also like this CH3, and you have CH2OH. Now, please understand that these two are not the same. Do you understand? Understand that these two are not the same. Yeah, this one and this one are not the same. Now, what is the difference between this guy and this guy here? Here we can see that this carbon here have three methyl with three carbon. If you check it very well, here we have carbon here CH3, and what CH3, right? Now here we have what hydrogen. Here we have CH2OH. So if you check it very well, here we have carbon, and carbon directly attached to each other here. Here we have hydrogen, and carbon attached to each other one here. Do you understand? Therefore, this guy will attract this guy because this carbon here have three. This carbon here have three carbon, but this only have one carbon. Do you understand? So this guy is greater than this other guy. Now, but it's not like that here. If you check this very well, this carbon here have what two hydrogen and what one oxygen directly attached to it. Do you understand? Now because this oxygen directly attached, this OH directly attached to it, it will attract this one that have what that carry three hydrogen. Do you understand? Three carbon. So this is what we have done here. Do you understand? So that is what rule number what 4. That is what rule number 4. Rule number what 4. So let me give you one for you to try. Let me give you something for you to try. If for example here we have CH2OH and you have CHClOH. So now which one we are trying this one? Yeah. Now let's say this one number 1. Number 2. Here we have A and here we have B. So we have CH3, Cl, CH2, Cl, and here we have CH3. Number 3, here we have Cl, OH. So here we have 4, here we have CH3, we have NH2. Okay, now go ahead and try it for me, right? Go ahead and try it for me. Leave it at the comment section. So let me put an atom that is multiple bonded to another atom is considered to be replicated as a substituent on that atom. Now, let me explain this for you here. If, for example, you have just an atom like this. Okay. Please look up here. Now, this guy is not bonded to oxygen here, right? And this guy what carbon guy is what like like triple bonded to what to nitrogen here. Now, whenever you have something like this, because here is called CN, just and this guy is called now this guy just like COH. Then here we have hydrogen here. Now, what it means, please pay close attention here. What it means that this carbon atom here, there is no bonded to oxygen here. That is oxygen is 2 times here. So the numbers of bonds that the atom is bonded to it determine how many times it's going to how many atoms is it. It indicates that oxygen is what is 2 here, nitrogen is 3 here. Just so when you are comparing atom here, probably you are comparing something like this. And now it's something like this CH2OH. Just now what it means here is that if you are comparing this guy and this guy here, understand that this one is multiple bonded to what to oxygen here. It means about 2 bonds. It means that this one have 2 oxygen, while this one have 1 oxygen. Do you understand? This one is only 1 oxygen, but this carbon atom that is not bonded to this oxygen is there is we have 2 oxygen. So here we have 2 oxygen. Now because here we have 2 oxygen, this one we have to ground this guy. That is me. Just that is what that is me. Now another thing I want to understand here is that when you have something like this, CnH2, here we have hydrogen, and here we have something like carbon. Just stand here. Now this guy have what 1 nitrogen, but this guy have what 3 what nitrogen. Just stand. This guy will have 3 nitrogen. So this guy will attract this one here. So it means that C double bond here and nitrogen is getting what CH2 NH2. Just very important here. So these are the priority rules you need to what take note of, because you're going to use them when you're assigning A and Z configuration and R and S configuration to what to isomers, to geometrical what isomerism. All this video is helpful. If this video is helpful, please leave a comment section that this video is what is helpful. So we are going to move to the next thing now. So if you have not checked out what optical isomerism, check it now. You see optical what isomerism, or you see E and Z what isomerism. Just go check it out.